Getting faster on the power up, your quiz answers would read like this: 1/2, 1/4, 3/4, 2/3, 1/10. Next row: 1/2, 1/5, 1/4, 3/5, 3/4. Next row: 2/3, 9/10, 1/2, 3/4, 1/4. Final row: 2/5, 2/3, 3/4, 1/3, 3/5. Your mental math would have rattled $5.50, $16.50, $7.50, 144, 125, 1/8, 72, and 7. The challenge problem read this: Letha has 7 coins in her hand totaling 50 cents. What are the coins? So I have to have 7 coins and they have to equal 50 cents. My first thought was, can I ever do it with a quarter? So I have 1 quarter. That's worth 25 cents. I could have 5 nickels. That would equal the other 25. Too much. Not enough coins. It's only 6 coins. If I have 1 quarter and 5 pennies, and then 1 dime, that's my 7 coins, but that's 25, 30, 40. Doesn't get there. So guys, I can't get there with quarters. So I'm down to dimes now. And here's what I did. I said, how do I get 50 cents, 5 dimes? Okay, that's too many, not enough coins. If I go down to 4 dimes, I need 2 nickels. So this is kind of like the challenge problem you had with cows and kids and heads and legs. As I drop this one down 1, I add 2 here, so I'm increasing it. So this is still 50 cents, and I'm up to 6 coins. I drop down to 3 dimes, I would bump up to 4 nickels. 30 cents, 20 cents, there's my 50 cents. 3 plus 4, there's my 7 coins. So 4 nickels, 3 dimes. Get a little pattern. Some of you might do guess and check. The problem with guess and check, guys, is there's a lot of things that you could guess and check at. So always look to see, can I come up with some pattern as the number of one goes down, the number of the other one goes up. So I start working my way toward those 7 coins. Okay? We'll start with a quick review from yesterday. We were measuring with that protractor device. Remember, acute less than 90, 90 is a right angle, obtuse is bigger than 90, and then a straight. So when I look on a protractor, the first thing I do is say, is it an acute or obtuse? If it's acute, I take the smaller number that it goes through. If it's obtuse, I take the bigger number it goes through. Our other shortcut for doing that was looking and thinking like a clock. Every hour on a clock is worth 30 degrees. So if I'm supposed to draw a 120 degree angle, I would think 120 divided by 30 is 4. So from 12 to 4 o'clock, and I could draw a 120 degree angle to do those things. Today we're moving on with polygons. This I call like the beginner geometry class, so we can start working with shapes, and then we'll be able to figure out area, volume, surface area, all kinds of things as we work through our book this year to get there. Make sure you have your yellow folder out to fill in some blanks, and you have your math book ready to cruise along as we start to work some concepts. Here we go on page 121. When 3 or more segments are connected to enclose a portion of a plane, a polygon is formed. The word polygon comes from the ancient Greeks. That means many angles. So poly means many, gon means sided angles. The name of a polygon tells how many angles and sides the polygon has. We have special names. Triangle, 3 sides. Quadrilateral, 4. Penta, 5. Hexa, 6. Hepta, 7. Octa, 8. Nonagon, 9. Decagon, 10. Undecagon, 11. And dodecagon, 12. Now guys, heptagon for 7, nonagon for 9, and undecagon for 11, those aren't that common. Every other one, though, you got to memorize, because we'll ask you questions all year long on how many sides on a dodecagon, or how many angles, or how many degrees in it. We'll be able to figure all those things out, so we got to have that. If you're not good at memorization, maybe you want to put some kind of bookmark in your yellow folder, guys, or into your book, and pay the price to go back to those things, because those are the resources you can use to figure those things out. Okay. Underneath that it says this: note, for polygons with more than 12 sides, we simply use the term n-gon, with n being the number. Thus, a polygon with 15 sides is a 15agon, 22gon, 28gon. Okay, so they just got polygon at it, you put the number in front of it to get there. Okay, the point where two sides of a polygon meet is called the vertex. We had that with the term angle. A particular polygon may be identified by naming the letters of its vertexes in order. Any letter may be first. The rest of the letters can be named either clockwise or counterclockwise. So the polygon below has 8 different names, whether you name them with what letter you start with and whether you go clockwise or counterclockwise. Okay, so guys, all they're saying is we don't care where you start, go in order. We don't care what order you go in as long as it's in order, and name every letter that's there. Okay, in your yellow folder, guys, for a polygon, I just want to stress that. It's, number one, means many-sided shape, but you have to use straight lines, okay? Angles are made with straight lines, so a polygon has to, number one, enclose a shape, which means it needs to start and finish at the same spot, and it needs to be made with straight lines. Okay, top of the page 122. If all the sides of the polygon have the same length and all the angles have the same measure, then the polygon is called a regular polygon. So you have a regular triangle drawn there, all the same sides and shape, and then you have an irregular triangle. You have a regular quadrilateral, we have a special name for that, that's called a square, same length of sides, same angles. Okay, so regular, the sides and the angles are the same. We'll use this a lot, this lets us do math off of that. They'll give you the amount of degrees, they'll give you the lengths, we'll multiply. If I give you the length of a quadrilateral and say the length of one side is 4 and it's regular, you know 4 times 4. If it's a hexagon, 4 times 6. Okay, so we'll work the math in some of these problems as we get rolling through those. Number 1, it says name this polygon. 1, 2, 3, 4, 5. 5 means pentagon. And so I wrote down a pentagon. B says, is the polygon regular or irregular? Are all the angles the same amount? Are all the lengths of the sides the same? The answer is no. So it's an irregular pentagon, okay? B, which of these figures is a polygon? No, it has a curved line. No, it's not enclosed. It needed that line. No, this is three-dimensional. Yes, straight lines encloses a space, okay? So no three-dimensional shapes, guys. That's not polygons, that's polyhedrons. Now we'll talk about the rest of our math class, which is similar and congruent. And then I'll go back and I'll fill in the blanks with you into your yellow folder. Two figures are similar if they have the same shape, even though they may vary in size. In the illustration below, triangle 1, 2, and 3 are similar. They all have the same shape. To see this, you can imagine enlarging, which means dilating triangle 2, as though we were looking through a magnifying glass. By enlarging triangle 2, we could make it the same size as triangle 1 or triangle 3. Likewise, we could reduce triangle 3 to the same size as triangle 1 or 2. Although triangle 4 is a triangle, it is not similar to the other 3 triangles because the shape is different. Viewing triangle 4 through a reducing or an enlarging lens changes its size, but it can't change its shape. Okay, into your yellow folder, guys, we have to do regular. All angles and sides are the same. That's really important. Then similar, it has the same shape, but it has a different size. Okay? Continuing on top of 123. Figures that are the same shape and size are not only similar, they're called congruent. So congruent I gave you guys, same shape and same size. Now I wrote that next line, which is really important. Congruent is also similar, but similar is not also congruent. So if two triangles are congruent, guys, they're also similar. They have the same shape. Congruent also has the same size to go along with it. So keep that straight as they ask you true-false questions for that. All 3 of the triangles below are similar, but only triangles ABC and DEF are congruent. Note that the figures may be reflected, which means flipped, rotated, which means turned, without affecting it. So they're not just going to be right next to each other, guys. They're going to twist those things. When inspecting polygons to determine whether they are similar or congruent, we compare corresponding parts. A triangle has 6 parts, 3 sides and 3 angles. If the 6 parts of one triangle have the same measure as the 6 corresponding parts of the other triangle, they are congruent. Referring back to the illustration of ABC and DEF, we identify the following corresponding parts. Angle A is the same as angle D, angle B to E, C to F. Now AB to DE, BC to EF, CA to FD. Okay, so you got to be able to spin that thing in your head. Notice that the corresponding angles of similar figures have the same measure even though the corresponding sides may have different lengths. So that's an important truth we'll use later on in the year. Same angle measurements, the size can vary. They'll always form a proportion, guys. Okay, so I just told you all those things, and then the last thing I want to point out to you is this. Corresponding parts, same angle or size in a similar shape. Mark with small lines. And so guys, in the middle of the page on the left there in your book here, those are those little tick marks we put. Anytime you have the same number of tick marks, it says this side equals this side. That side equals that side. So if I ask you to draw similar triangles, and I said, here's triangle 1, and here's triangle 2, and this angle is the same as this angle. I put one tick there, I'm going to put one little tick mark there. And this angle, I'll put 2 tick marks, is the same as this angle. 2 tick marks. This angle up here, 3 tick marks, is the same as that angle there. So anytime the number of ticks are the same, it tells me that angle is the same. Now I can't do that with the sides, guys, because these sides aren't the same length. But if I drew 2 triangles, that's kind of ugly, and I put 1 tick mark, that tells you these are the same length. 2 and 2, same length. 3 and 3, same length. Okay, so even though my drawing is pretty ugly, this tells me that they are the same length. Okay, so that's what they're trying to tell you with those marks. It's how we do math. That's like saying, is this a right angle? No. How do I know? There's no box in it. Is this a right angle? Yes. How do you know? You put a box in there. So we're just learning to draw math the right way. Okay, example 3. Which of these quadratos appear to be similar? Same shape. So this is the same shape as that. It's also the same shape as that. So 1, 2, and 4 appear to be similar. They look the same shape. B says, which of these quadrilaterals appear to be congruent? Congruent, same shape and same size. This one doesn't have the right shape. This one doesn't have the same size, so that one's out. Turning the page, number 4. Which angle in XYZ corresponds to A in ABC? So I have over here ABC. They're saying what's the same as A? A appears to be the right angle. Angle X appears to be the right angle, so I can spin that thing in my head. And B, which side in XYZ corresponds to BC? BC looks like the long diagonal, so this would be the long diagonal. That is ZY with a segment sign over it. You could have switched that around and done YZ. Okay, the other thing when it comes to writing math, guys, if they're corresponding parts, if they're similar and congruent like that, we should write them in the same order. So I wouldn't even have to look at that, I could just look at that. What that means is this. XYZ, the X came first, corresponds to what? ABC. A was the first one mentioned. So A should go with X, B should go with Y, C should go with Z. That's how we write math correctly when they're similar and congruent. So that's good things to know, especially when you get into geometry class in high school, to make sure you write them in the correct order. Okay, you got a huge bunch of letters in the practice set if you want to practice on those things. If not, get out your answer key and get ready to do some more. 6th grade, here we go with our problem set. We start with number 1. Number 1 says this. The Collins family drove 28-25 coast to coast in about 6 days. They drove about how far each day? So I have a division problem of a total of 28-25 being divided among the 6 days. Goes in there 4. That's a 24. Gives me a 42. Goes in there 7, which is 42. Brings down the 5. Goes in there 0 times and 5, 6. You could write that. It said the word about, so I could round up to 471. Either one of these answers, guys, is good. Don't forget the label of miles. It all depends on how you read the word about. Number 4. 1 billion is how much greater than 10 million? Use words to write your answer. So I start with 1 billion, guys. That's 9 zeros. 10 million is 7 zeros, because a million has 6 and I have a 10 there. And then it's a big subtraction problem. So then I have to write that in words. That's 990. And we're in the millions position. So I have 990 million. Everything else is 0, you don't have to write it. Number 5, arrange these orders a number from least to greatest. So I always start with a negative, 1. Start with a changeover, 0. Fraction, 3/4. Whole number, 1. And then improper, 5/3. B says, which of these numbers is not positive? Well, -1 is negative, but guys, don't forget the 0. 0 is not positive or negative either. So they asked me not positive. The reason they said not positive is because they were testing you on that 0. Number 8, write each number as a reduced fraction. I started with 2%. Percent means out of 100. Divide both numbers by 2. Gives me 1/50. 12 over 20 gives me divisible by 4. Gives me a 3 and a 5. And 6 and 15/20 is divisible by 5. Gives me a 3 and a 4. And don't forget your whole number of 6 3/4. Number 9, for each fraction, find an equivalent fraction with a denominator of 30. So I have 4/5 times my number to give me something over 30. That's a 6 here, so it's a 6 there. 4 times 6 is 24. Next one is 2/3 times something gives me 30. That would be a 10 on the bottom, so you need a 10 on the top. The multiplication gives you 20. Last one is 1/6 times something gives me something over 30. That would be a 5 on the bottom, so you need a 5 on the top. Gives you 5/30. Number 10, name each of these figures. So I count 1, 2, 3, 4, 5, 6, 7, 8. 8-sided is an octagon. B, I count 1, 2, 3, 4, 5. 5-sided is a pentagon. C is a circle. And then it says, give the reasons for your choice. Tell which one is not a polygon. C is not a polygon. Why? Curved lines. Polygons are made with straight lines, guys, and angles. Number 11, draw a triangle that has one obtuse angle. So guys, just draw an obtuse angle and now make it a triangle by connecting the dots. Good. B says, what kind of angles are the other two? Well, that and that are both acute angles. So that's your answer for B here. Now, guys, what they're trying to teach you is 2 angles on every triangle is always acute. It's this third angle that we name it of. If the third is obtuse, we call it obtuse. If the third angle is right, we call it right. If the third angle is also acute, then it's acute. But don't get confused. 2 angles will always be acute. Turning the page in your math book, you're up to number 13. 13 says which properties are illustrated. You have 1/2 times 3/3 equals 3/6. I hope you recognize this as 1. Multiplying by 1 is identity. We've already had that once this week. We got it again. The next one is 2/3 times 3/2 equals 1. And we stressed anytime it equals 1, it's the inverse property. Multiply by 1 is the identity property. Flip your answer key over. We're at 16. Missing the second in subtraction, I still subtract. 5, 6 minus 1, 6. Subtract the top 4, bottom stay the same. Reduce by dividing by 2 gives me 2/3. Number 19, multiplication. I have 3/2 times 2/4. 2's are on the top and the bottom. Cross them out. I'm left with 3 and a 4. Number 21. I'm going to do 75 times 8. Put my 2 zeros down. That's 40. Carry the 4. That's 56 plus 4 is 60. 1, 2, 3. 1, 2, 3. So guys, I just brought the zeros that were here straight down and did the multiplication to get 60,000. 24, what percent of a pound is 8 ounces? Well, I know that there are 16 ounces in a pound, so I have 8/16. If I divide by 8 over 8, that equals 1/2. I hope you have 1/2 memorized as 50%. 25, how many degrees are in a fourth of a circle? Well, that was part of our lesson yesterday, guys. I divide by 4, that gives me 90 degrees. So A is 90 degrees. B, I'm going to do the same thing, but this time I'm doing 1/6. So I have 360 divided by 6 is 60 degrees. So just remember the review. Circles, 360 degrees, divide by my denominator. Then I usually multiply by my numerator, but the numerator is 1, guys, so I don't need to do that. 26 says use a protractor to draw a 135-degree angle. So if I draw my straight line, 135 is going to be obtuse, guys. I go over here and get my 135-degree angle. B says 135-degree angle is degrees less than a straight angle. So guys, that's just saying if you went the other way, what would be less? Straight angles add up to 180. If you're looking at your protractor, you had a 135 over here and you had a 45 over here. So you have 45 degrees for letter B. Or you could have said straight angles are 180. I used 135, so it's a subtraction problem and gave me 45. Those of you without a protractor, you might have noticed that a 45 is half of a 90. So the easy way to draw 135 is like this. I draw my perpendiculars. This is 90 degrees. And then I cut this in half. That would be 45. 90 plus 45 equals 135. And then I just erase my little 90 helpful hint there. And I could also erase if I wanted the rest of this. And there I have my 135-degree angle without my protractor. You're realizing a protractor is a good thing to have. Last but not least, number 29. Write 2 1/4 as an improper. Multiply, add 9 over 4. Multiply the improper by the reciprocal of 3/4. The reciprocal of 3/4 would be 4/3. 4 on top, 4 on bottom, 3 goes into 9 3 times.